Join me in giving a big seaborne welcome to Valentin Troll. Thank you, Valentin.
Thank you very much, Nick. So, welcome this morning. And I have a little program for you over the next few days, and this is about mainly geology, and specifically about volcanology. Well, geology is often considered a little dull, but volcanology is not. So I hope to bring my type of volcanology and geology a little closer to you. I've been working in the Canary Islands for some 25 years by now, and I've studied the volcanoes there for quite some time, and I've seen several of the eruptions there, and I'm gonna tell you today about the origin and the geological highlights of the Canary Islands. So where are we? Well, we are off the northwest coast of Africa, and here we have 7 major islands, the Canary Archipelago. And there is a tiny little island, it's called La Graciosa, and the people on La Graciosa were very unhappy of not being considered a main island, so they put in a proposal a few years ago, and now there's 8 major Canary Islands. So, but I will not really talk much about La Graciosa. There's only one really important thing, and La Graciosa has inspired the story of Treasure Island. So actually, if there is a treasure, a pirate treasure buried anywhere in the Canary Islands, it's likely there, but I will not tell you where it's lying. So the Canary Islands have been very important since the early day of European seafaring, because they are very important for navigation. And on the left-hand side here, you see a drawing. It's a Dutch drawing from the 1500s, actually, and it shows Teide volcano. And of course, it's a little out of proportion, but the important point here is Teide sticks out through the clouds, and you can see the clouds, and Teide peaks above them. And this is actually what sailors could see from a far, far distance. And this is why this has been very important. But Teide has also been very important. Later on, many important scientists have come here. There was Charles Lyell, which was the teacher of Darwin, and then there was Humboldt, and I'll talk a little bit about Humboldt later in the cruise, about his week on Tenerife and his discoveries. But today, I'd like to focus on the main Canary Islands, and here they are lying off the seaboard of Northwest Africa, up to about 500 kilometers to the west. And a question I get really very often is, have these islands been connected? And we'll talk a little bit more about that later, but the answer is no. They are all independent islands, and they stick out from the seafloor. They're actually really tall edifices, and they have not been connected, with one exception, and that is Lanzarote and Fuerteventura. They actually have a connection, but I'll show you a little later. So, usually we have less than 5% of the edifice of an island sticking out here in the Canaries. Most of the island is actually underwater. And they rise up from a seafloor depth of several thousand meters, and Teide volcano with 3,700 meters above sea level is actually over 7,000 meters tall. Well, Mount Everest is considered the highest peak on Earth, but actually Mount Everest starts really high up already with its base level. So Teide from the seafloor up is actually taller if you were to just measure the direct height of the edifice. So no formal land bridge, as I said, and the islands are all independent edifices. And that is very important later on when we talk about the origin of the islands. So I'm going to give you a quick run through now, and I'm going to introduce all the major islands to you, and then we're going to talk about some geological highlights of the island. So Fuerteventura is not the largest of the islands, and it's got a pretty flat topography. It only reaches about 800 meters above sea level, and it has about 115,000 and 116,000 people living there, and it's got a reasonably low population density, with about 70 people per square kilometers. Let me give you a flavor. The UK has about 230 people per square kilometer. Sweden, where I live, has about 23 people per square kilometer. So, and Fuerteventura, being very close to the African continent, it actually receives a lot of sand, a lot of dust being blown over from Africa, and it's locally referred to as Kalima, the African winds, the hot African winds, and this dust is then blown out onto the Atlantic. It's actually very important to keep the Atlantic ecosystem flourishing because it brings a lot of nutrients, and the dust reaches all the way to South America and also North America. And sometimes when you have dusty days in Florida, it's actually coming from the Sahara. And Fuerteventura, being close to the African continent, has a lot of sand deposition, has a lot of white beaches, which is very untypical for young volcanic islands. But this is actually not material that's from the island itself. It's been blown in from the Sahara. So this is how it looks when the sand is not there. It's quite barren, it's quite eroded, actually, the island. It's a bit like the Sahara Desert, and Lanzarote, the neighboring island, is actually very similar. So Lanzarote is also pretty flat, 670 meters in altitude. Population is about 150,000, and we have a population density of 180 people per square kilometer. Lanzarote has beautiful mountains and beaches, and there's a big salina which you can visit. So this is a reminder of the old days when salt was produced on the islands in a large scale. The island is also known for its wine production, and it uses a very specific type of making wine, and I'll talk a little bit more about this in my lecture on volcanic resources and volcanic agriculture, because there was a big eruption in 1730, and this is now the core of the Timanfaya National Park. And after the eruption, the people of Lanzarote, they learned how to use volcanic particles in agriculture. And one of the biggest islands is now a little bit further to the west. That's Gran Canaria. And this is also a little taller. It's almost 2,000 meters in elevation. And it has 850,000 people living there. And it has a very high population density with almost 550. So the population density is double that of the UK or Germany or France. So the island is almost circular, and it's about 45 kilometers across. And it has an old shield, which is rocks that are marked here in blue on the map. They look through in some places, but it's got much, much younger rocks in the northwest. All the recent volcanic activity, and recent means of in the last few thousand years, are actually in the northwest of the island. So it has a little volcano that sits in the northwest, and the people locally call it Little Teide because it has the shape of Teide volcano on Tenerife. And you can actually visit there in the town of Galdar, where there's also a lot of aboriginal remains, like the famous painted cave, for instance. Another aboriginal relic is Roque Nublo. It's a volcanic rock formation in the center of the island, which was worshipped by the Aboriginal people. And there are several other hill fortresses where the Aboriginal people were trying to fight off the Spanish invaders at the time. And here's Roque Pentaiga on the left. And this was actually the site of an Aboriginal victory over the Spanish invaders. But of course, it didn't last. And on the right-hand side, we have Cenubio Valeron, which was an old grain store used by the Aboriginal people. Another important feature is this volcano here. This is likely the youngest volcano on Gran Canaria. It erupted about 2,000 years ago, precisely 1,950 years ago, and it sits right to the present-day capital of Las Palmas. And this is not a good combination. Obviously, the Spanish settlers didn't really understand volcanoes so well, and they built right next to the most likely most active area. However, on the hills or on the slopes of this little volcano, we have now a golf course, and we have several vineyards. It makes a very good wine. It's called La Caldera, after the little caldera trough in the volcano. So Gran Canaria had the largest population of Aboriginal people. They, from DNA studies we know, came from Northwest Africa, and they probably had a population of 60,000 prior to the Spanish arrival, and there was literally little villages and small towns. And there, if you have an opportunity, you could also go to the Museo de Canario in Las Palmas, in the capital, which has beautiful artifacts from those days. So Tenerife is the largest of the Canary Islands, and it's also the tallest with 3,700 something meters, and it's got 917,000 people living there, and it's got a population density of 444. The flag of Tenerife looks identical to the Scottish flag. And it confused me when I was a PhD student for quite some time, but it is what it is. So there is a double flag, believe it or not. So Tenerife has 3 arms, and we'll talk more about this later. And in the heart of the 3 arms, there is the jewel in the crown of the Canary volcanoes, and that's Teide volcano. Teide volcano did not erupt in historical times. Its last eruption was about 1,200 years ago, so there's no worry that it will erupt very soon again. And today you can actually go up there if you have the opportunity. There's a cable car taking you up there, so you can go up to 3,500 meters. But if you come from sea level up to 3,500 meters, a lot of people will have the first symptoms of altitude sickness. So be a little mindful of that when you go up there. My 15-year-old daughter was just saying, "Dad, can we go, please?" So she didn't enjoy that at all. So I'm warning you. So Teide National Park is the largest national park in the Canary Islands, and actually one of the largest in Europe. And it has a lot of visitors, over 4 million people. And I have a lecture about the national parks in the Canary Islands as well a little later. So it actually has more visitors than Yosemite National Park, can you believe it? So the most photographed rock formation in all of Tenerife is this feature here. It's called the Tree of Rock, and it's an erosional remnant. And there, let me see whether I can get this to work. Oops. So there you see a human for scale. There he is, sorry. And as you see, it's getting actually quite thin here. Over here you see the base is very, very thin. And this happens when the rocks above are more weathering resistant than the rocks below, and then the base gets eaten out, and sooner or later this tree of rock will fall over. There is no way to save it. There was a similar rock on Gran Canaria. It was called the Finger of God, and one stormy night a few years ago, it fell over. It was a big shock to the local population, and there was proposals to put it back up and stick it together and put glue in there. And my colleague, Juan Carlos Caracedo, one of the most eminent geologists on the islands, who will actually join us for 3 days when we reach Tenerife, he had to write a report recommending that it's not a good idea to stick rocks together. They will just fall over again. So the Teide volcano sits in a beautiful older volcanic setting, the Las Cañadas caldera, which was a big explosive volcano, but it's now extinct. And this is the view from Teide down into the Las Cañadas caldera. And there, just in the far distance, you can just about see the outline of Gran Canaria Island. And this is from the cable car, from the gondola when you go up there, and on the bottom right, there's the cable car station. And you can walk around freely, but to go to the very peak from the cable car stations, you need a permit. So you can go up to 3,500 meters and walk around, but you're not permitted to go all the way up. They restrict access for the simple reason that it's a protected area. There was sulfur mining up there in the Spanish Civil War, and there's an image here on the lower right. And this is the actual crater on the left-hand side. It's basically a mine site, and you are not allowed to modify it any further because it's already a little bit spoiled because of the mining activity in the wartime. So La Gomera, we will not go there on this particular cruise, but La Gomera is famous for its roques. It has a bunch of sticking up rock masses, the roques, And the area is not so big, it's not the biggest island. The elevation is also only about 1,500 meters above sea level, population only 20,000 people, and population density is very low with about 60 people per square kilometer. And the most famous rock formation on Gomera is Los Organes, the organs. And here you see the organs in the middle. It rivals the Giant's Causeway in Northern Ireland. And it's a beautiful rock formation. It's very hard to get to. You usually take a boat because hiking there is not a very nice experience. So here's a few slides, and these rockets, they're actually former vents, they're former magma intrusion sites. They have fed little volcanoes, and they're now eroded out. La Gomera did not have any volcanic activity in several million years, so this is why these rockets now stick out, and they're very proud. And the one in the top right is the Roque Argando, and this has been also an Aboriginal worship site, and there was actually some artifacts right on the top, but unfortunately, somebody stole them. Not so long ago, probably in the 1980s. It's not quite clear who that was, but they're gone. It takes quite a climb, so we know that the culprit was certainly a good climber. So here's a few more of those impressions, and Roque Argando is even in the coat of arms of the local municipality, and there are several other ones like Fortaleza, the fortress, which was also a site of resistance of the Aboriginal people against the Spanish invaders. I'd like to talk a little about El Hierro now, which is the smallest of the main islands, and it's got an elevation of about 1,500 meters, population of only about 11,000 people, and it has the lowest population density with just about 40 people per square kilometer. The island is famous for its hydropower plant. It's got this rather amazing system where water is pumped up to the mountains via wind power, and it's stored in an old volcanic crater, and then it's released to produce energy. It's self-sufficient, and it's won several awards from the European Union to serve as a model for a self-sufficient, electrically self-sufficient island. So it's also famous for the holy tree, the Garaoi. When the Spanish invaders came, they pushed the Aboriginal people into the mountains, hoping that they would starve and die of thirst. But the Aboriginal people had a little secret. They had the holy mountain, Garaoi. What the holy mountain did was, it was actually capturing clouds, and water was precipitating, and it was dripping down, and the tree was standing on an impermeable layer. So there was actually little puddles forming. And so the Aboriginal people were able to sustain themselves for considerable time, and the Spanish were unable to defeat them for quite a long period. So I'd like to talk about La Palma now. We will also not go there, and it's maybe a good thing because La Palma is the most active, volcanically active island in the archipelago. It had a whole series of historical eruptions, the last one only 2 years ago. And elevation is about 2,400 meters, population is about 82,000, and it's got a population density of 116 people per square kilometer. And here's a few images on the right-hand side from the 2021 eruption. And nobody died, actually, nobody died from volcanoes in the Canary Islands in historical recorded time, which is quite fascinating. But the devastation was rather immense. So La Palma has a northern shield, a northern round area, and the southern ridge, and it's the southern ridge, the Cumbre Vieja ridge, that is so active. Cumbre Vieja means the old ridge, but actually geologically it's the new ridge. And it comes because of a misnomer, and this is because it's a forestry term. It was named after having an old forest as opposed to other areas, but geologically it's exactly the other way around. So you can see the vents here on the ridge, and the ridge continues underwater for some 20 kilometers. There is also submarine volcanism there, and we know from seismic stations that frequently we have small eruptions there underwater as well. So here's a few images. On the top left, the 1949 eruption. In the center there, the 1971 eruption. And on the right-hand side, the 2021 eruption. And the ridge had a whole series of eruptions going back to 1585. That's since the Spanish records were actually looking at volcanoes. And it is the most volcanically productive area in all of the Canaries. So if you want to see a volcano close to your house, that's where I would buy some property. So here's a few impressions, and I will give you an entire lecture on the 21 eruption. I was asked to help during the crisis, and so I was part of a Spanish team that was deployed in the eruption site, and we had permission to go into the exclusion zone. It was exciting, but also very challenging at the time. So if you're interested, join me for that lecture, where I'll give you some more detail on the eruption itself. So now, I'd like to move on to the second part of my presentation today. After having given you a run through the different islands and their individual peculiarities, I would like to talk a little bit about how volcanoes like the Canaries actually come about. And I want to start with this drawing here from Athanasius Kircher. This goes back to the 1660s. And Kircher was very perceptive. He was a monk, and he was not traveling the world, but he was thinking a lot. And he pictured volcanoes to come from a fire inside the earth. Later on, people disputed this, and it got forgotten. But then, of course, now we know he wasn't entirely wrong. So let's have a look at this. Here we have an image of the Canary Islands without the water. So this is from the seafloor up. And one important feature is that the islands get smaller towards the west. And that tells us something about how they formed. And there is a tiny little island here on the right. Actually, it's not an island yet. It's underwater. It's called Las Hijas. And this may be the next volcanic island growing. So it seems that these islands have an age progression, as we call it. That the youngest islands are in the west, and the older islands, they're in the east. And this seems to be consistent with the erosional pattern. This is why I have purposefully given you all the elevations, because there is the very large but flat islands in the east, and the very small and reasonably steep but not very tall islands in the west, and the big, large and tall islands, they're actually in the center. So we get the impression that there is an age progression with the elderly islands in the east and the very youngster islands in the west. So here is another image that shows you this, because if we go submarine towards the north of the Canary Islands, we find drowned islands. There's yet more older islands that we don't see anymore. They used to be islands, and they are even older. So we get the sense of an age progression from something like 60 million years ago to only about 1 million years ago. That's the El Hierro situation. So, and if we look at the age dates, we can date rocks with radiometric methods, then we find that the oldest rocks on Fuerteventura are about 20 million years old, and the very oldest rocks we find on El Hierro are only about 1 million years old. So there is this age progression. Now, there's a big scientific debate, and it's raging. We can't see that here, but people are very, very intense about this, and this is about, is the Canary archipelago a cluster or a chain? And this is something people spent their entire time with, can you believe it? And here, the big discussion is, if it's a cluster, then it's likely fracture related. And people speculate it could be related to the Atlas Mountains, which I'm showing in the top right here. And other people say it's more like a Y, it's more like a chain where one island pops up, and then it stops, and the plate moves on. So I'm going to share some of the different features of this, and I clearly have an opinion which of the two models is correct, and I'll try to convince you of my view here, of course. So here we have the Azores Island on the top, and the Azores, they sit right on a fracture zone, and all the Azores Islands are really strung out. They're elongate, and they have no age progression. The islands of the Canary archipelago below, they are more blobby, if you will. So they're not strung out, and they have also different orientations. Sometimes they point this way, sometimes they point that way. And let me see whether I get this. Yes, here we are. It's a bit fickle. So this is the Azores, and there's a lot of earthquakes. Each of these little dots is an earthquake. There's a lot of earthquakes in this fracture zone around the Azores. And when we look here, there's a lot of earthquakes in Morocco. We just had a huge one recently in Marrakesh. But if you look into the ocean off Morocco, there's no earthquakes. So it doesn't look very convincing that there is a fracture zone continuing from Morocco to the Canary Islands, because we would expect a lot of earthquakes, wouldn't we? So the more compelling story is that they are actually little Bunsen burner volcanoes that sit under the crust, and the crust is actually moving. And if you were to do that, you could take that little geological exercise, which we call an Euler pole. You find a common point of rotation. And if you do that for the Canary Islands as well as for the Madeira archipelago, you find that there is an Euler pole, a common point of rotation, somewhere in the North Atlantic. And some people believe you could even explain the Cape Verde Islands with the same Euler pole, although I'm not entirely sure. But this would imply that they are actually changed rather than clusters coming from fractures. So, and people have done seismic tomography. That's a method that allows you to see whether there's anomaly deep down in the planet. And it shows that the Canary Islands, which I'm showing in the top right here, up here, they actually have this red area underneath them. There is a deep mantle anomaly that feeds material all the way from the Earth core up to the Canary Islands. So, to give you a feeling here, let's see whether I can make this work. There's a little animation. So this is how I think the Canary Islands are formed. We have this anomaly in the deep mantle that feeds up hot material. The hot material produces lava. The plate above the anomaly moves with about 2 centimeters a year, and this is where we make the older islands first, and then we make the younger islands. The older islands then get eroded, and eventually the younger islands will share the same fate once they have gone through this growth stage, with Tenerife being now the most prolific of the islands, being in its bloom, if you will, and the islands to the west being just about in their early stages, while the islands to the east, they're close to drowning. So this is a reconstruction of the Earth, and we have several of those features. One of them is Iceland, one of them is Hawaii, and the Canaries would be shown here in the very bottom of this diagram on the left. So let me flip this around for you. So this is where the Canaries would be. It says Africa there. And this is now just turned around with Africa now being on top. So, oops. So here we have these stationary anomalies that produce these little chains of volcanic islands almost randomly in the ocean. So, having explored this, I'd like to talk for the last little while of the presentation about the special geological features. And here I'd like to touch on 3 things. First of all, rift zones and giant landslides. The Canaries are geologically famous for giant landslides. Then about lava tunnels. The Canaries have the longest lava tunnel in the world. And I will also talk very briefly about some recent historical eruptions. So this is the island of Tenerife, and it has 3 arms, 3 rift arms. And all the eruptions, which are marked here in black in the top right, all the historical eruptions happen along those rift zones. And geologists call it a Mercedes star pattern. It's usually 120 degrees in between the rift zones. And we see them also on the other islands, and we see them also in the old shields. In the corners of Tenerife, there's some older little volcanoes. One is called Anaga, the other one is called Teno, and they also have these triple-armed rift zones, very peculiar. And if you look from Teide volcano down the northeast rift zone, you have this long ridge that continues for tens of kilometers all the way to the old Anaga Shield. So now when you go to Anaga and you look back, then it looks like this. It's just the same view in the other direction with Teide volcano towering in the center of the island. So this long ridge, similar to the ridge on La Palma I mentioned earlier, that's where volcanism occurs in the Canary Islands. So, and La Palma, as I said, has exactly that same ridge, the Cumbre Vieja ridge, and ridge volcanism is typical for the Canary Islands. So, and La Palma also, in between the ridge and the old shield, has this giant embayment, and this is important. This is a giant landslide scar. The Canaries have had a whole series of large landslides. It's been a big media row some 20 years ago because some people postulated that if La Palma collapses again, it would produce a mega tsunami. It would produce a wave that is so large that it will reach the eastern seaboard of the US. And it will still be tens of meters tall. So, and where does this discussion come from? It comes from this single fracture on the right-hand side. You see that fracture in this photo? This photo is from 1949. It is a crack that opened up during the 1949 eruption. And it opened up, and people started to get really worried that part of the island will slide into the ocean. And it triggered an investigation into giant landslides. And although we have not seen such a landslide in historical times, actually there is very good evidence for these landslides in the ocean floor geology because we see the avalanche deposits from these landslides. And indeed, all of the islands had these giant landslides. They are luckily very infrequent, but here's some headlines from the days when this was discovered some 20 odd years ago. And true or not, if such a wave were to travel across the Atlantic, it would be probably quite serious. And here's a numerical model of the travel speed of such a wave. So here we have the island of La Palma in the top left, and if there was a giant landslide, it shows here that within about 9 hours, this wave could hit Florida. And there was a National Geographic program a few years ago, and I had the pleasure of participating in there, and they were looking at the effects of such a wave. I was telling them repeatedly that the probability of such an event is extremely tiny. But, well, the final program still insisted, oh, it can do this very quickly and it's a real risk and it will kill all the people in Florida. So, yes, if it happened, it might. But these things happen so rarely that the chance of this happening in our lifetime is almost zero. So, but it's a reality, it happens, and we see the collapse scars in all the islands. And if you go to El Hierro, if you do a day excursion, have a look at the El Golfo collapse scar, which is the one in the north on El Hierro Island. This is the youngest of the large collapses. And here's a geological map, and you see the green area in the north of the map. That's the young volcanics that are filling in this collapse scar. So between these rift arms, we often have material that slides into the sea, and there's a real connection between rift arms and giant collapses. This is the El Golfo collapse scar. It's the tallest cliff in Europe with over 1,300 meters, and this collapse happened about 140,000 years ago. Lucky for us, these events are spread out on a frequency of about 400, 500, 600,000 years ago. If this was the youngest, it's a few 100,000 years to go statistically until the next one will occur. So, but there's a few older ones. Here's another embayment on El Hierro. It's called the El Jolan landslide, which is in the southwest. And then we have the San Andres landslide. And there we even see the landslide scar, which is in the bottom right here. There you see a fracture zone that is exposed. And here is me trying to climb the fracture zone. Let me see whether I can get this going. Here we are. So this is my valiant attempt to get a sample from high up on the fracture zone. And the reason for that is the fracture zone is actually glassy. the friction of the fault was so high that the rocks actually melted. Can you believe it? So, and also on Tenerife, we have these large landslides. So here, the Las Cañadas caldera is likely also one of those old landslides, about 200,000 years ago. And Teide volcano, the new big volcano, is actually growing inside the landslide. And even Gran Canaria has a big landslide. I always describe Gran Canaria as having the shape of an apple. And it's got a bite in the apple in the northwest. You can just about see that. And that is an old landslide as well. And here, the photo on the left shows you the curved outline of that old landslide scar. But this landslide went down several million years ago. We're going to the eastern islands very soon. And here's Andina Peninsula. And Andina Peninsula also has a curved outline. And again, this used to be an old landslide. It's barely recognizable now, and this is a very remote area. In fact, believe it or not, this was an area that General Franco was renting out to Adolf Hitler in the Second World War. The southern part here was a U-boat supply station. And yeah, after the war, it went back to Spain, obviously. But the narrow bit there was actually the boundary, and nobody was allowed to go in that area because U-boats would secretly dock there and get resupplied. So a few words about volcanic caves. They form when lava flows inside a big lava flow. And when they drain out, we get these empty tubes or tunnels. And sometimes we have drip features in there, like the lava drip stones that I'm showing here in the top right. And some of the caves are literally tens of kilometers long in the Canary Islands. So here's a few impressions. If you have a chance, for instance, if you're on Tenerife, you can go to the Cueva del Vientos, the wind cave, and this is one of the longest on the island. And here you can actually go inside. It is reasonably accessible. And here on the right, I'm showing you some active caves forming on Hawaii, so you get an idea. So this is lava that flows under a cooled crust, and once they drain out, you get these empty tubes. So here's a little sketch of how they form. If you have a lava flow, you get the crusting on top of it. It's a bit like a skin on a hot chocolate, and then the liquid underneath still moves, and it can produce these situations. So, and sometimes there's little points above the lava that flows underground, and there you might have little cones. We call them hornitos, rootless cones, and actually it's very good to have them because they allow you to map the tunnels under the surface. In the old days, before we had ground penetrating methods, you need to check whether you actually have a lava tunnel underneath your ground before you build a house, and looking for those hornitos was very, very useful. So here is a few impressions, and this is my colleague Juan Carlos Caracero from Tenerife. And I should actually point out that these caves are actually very intriguing because not only have they hosted some fossils and some animals, they also actually have some new species in there. Certain spiders, for example, that are on land quite colorful on the surface, but once they move into the caves, they don't need color anymore, so they go either transparent or black. So some of the caves have a lot of the spiders, unfortunately. This is now a short mention of Mr. Cesar Manrique. He was an artist on Lanzarote, and he loved lava landscapes, and he worked a lot with them. He also built sculptures, like here in the top left, but he actually lived in a lava cave. And some of them he converted into all sorts of things. He had a swimming pool in one of the lava caves, and he actually even built a concert hall and a restaurant in some of the lava caves, and you can still go there today. It's quite a show, I have to say. So here's the concert area in the lava cave, and they are, well, frequently hosting concerts of all sorts, and they are open for visitors. So my last few minutes I'm going to spend with a very quick word about historical eruptions in the Canary Islands. And not all the islands had eruptions, but 4 of them had, 3 onshore and 1 offshore. El Hierro had 1 offshore. All the 3 yellow islands here had historical eruptions onshore. So here's a table. I'll spare you the details. I had a few handouts there with the tables in there, but this lists all the eruptions. We have, well, about 20 eruptions that are recorded, and they're all of very similar type, so that's good for the volcanologist. And we had a bunch of them on Tenerife, and I'll talk more about the Tenerife eruptions when we talk about the Teide National Park in one of the other lectures. For now, I'd like to briefly touch on the Timanfaya eruption of 1730 to 36, which is the centerpiece of the Timanfaya National Park on Lanzarote. And it was a large eruption, and it lasted very, very long, actually. It covered 23% of the island, and most of the people were evacuated back then. So this was quite a shock for the population and for the settlements on the island. And here we have now the national park, the Timanfaya National Park. The little emblem, the devil, it's actually going back to an Aboriginal legend of a devil living inside the volcanoes. This particular devil was actually designed by Cesar Manrique, the artist I've just introduced. And the area on the map on the left, that's the national park now. The national park is fascinating, but you're not allowed to roam freely. You can go there, but you're only allowed to visit it in a bus tour or on camelback. So you can take your pick. So this is how Timanfaya looks like. Here's the vents, the little cones and craters from the 1730 eruption. And it's a rather barren landscape. And it's of course important that people don't walk around there too much, because there's worries that we might bring all sorts of seeds in our shoes, and that could of course bring invasive species, and that's of course to be avoided. So here's a few more impressions of the fascinating landscape in the Timanfaya National Park. One thing that you will find frequently on Lanzarote is actually these type of rocks. These are mantle nodules. These are pieces of mantle, and they contain this mineral called olivine. Olivine has a very light green color, and apparently Cleopatra loved it. She had necklaces and earrings from it. It's supposed to calm you down and give you a good, calm energy. And on Lanzarote, you will have plenty of opportunity to purchase some of them. It's actually rather inexpensive because there's loads of it, and it comes from deep inside the earth. It comes up in these little nodules that the lava spring up. So these nodules would form about 80 to 100 kilometers on the ground. So these are messages from deep inside the earth. In the national park, there's still heat there. There's still displays of heat, and what the local guards do, they often put a little bit of straw or so onto one of the vents, and then you will see it lights up in flames almost instantaneously, because there's still several hundred degrees of residual heat inside the national park. And in other places, they pour water into a little hole, and then you have to wait for 10 or 20 seconds, and then you have an artificial geyser coming up, and it sprays out hot water. So this is what I'm showing here. So if you have a chance and are interested, it's well worth a visit. So 2 more eruptions I'd like to very quickly touch on. The offshore, the submarine eruption on El Hierro in 2011. There is, again, like on La Palma, a ridge that goes offshore, and we had an eruption there in 2011, 2 kilometers offshore, and this is how it looked. It was next to the village of La Restinga. At that time, the Spanish authorities were a little overwhelmed. It was 1 year after the Eyjafjallajökull eruption in Iceland, and people were extremely concerned. So a lot of support personnel was moved into that village, and the village was evacuated, but at no point did anything ever reach the village. It was an entirely submarine eruption. Here's a few impressions of bubbling up on the ocean. There was even floating lava balloons in the ocean offshore, but the village, as you see it here in the background, was not actually concerned at any time. So then La Palma, I mentioned it before, there was a whole series of eruptions, 1585, 1646, 1677. The drawing on the left goes back to 1677, and the latest eruption was 2021. Here's a few photos. The black and white photos are from 1949, from the 49 eruption, and the colored ones are from 1971, which is the year I was born. So from that point of view, they are pretty kind of dated eruptions now, because the last one only 2 years ago was not just the biggest one, it also happened in a very densely populated area. The previous eruptions were in remote areas, but this one was not. So it caused a lot of destruction, and it built up a new volcano. You see here on the left, Dia Uno, the first day of the eruption, and then after only 3 months, a new volcano grew, and you can see the size of the volcano in the lower left. Vast areas of banana plantation and settlements were covered with lava, and here more than 2,800 buildings got destroyed, of which 1,300 were homes, 1,500 were utility buildings. Over 1,000 hectares of plantation and farmland were destroyed. Over 70 kilometers of vital roads were destroyed, and houses were literally buried in lava or in ash, as you can see here on the right-hand side. However, no human life was lost, which is an amazing feat in such a situation. So big credit to the authorities there for handling the eruption to this, bringing it to this situation that nobody really got hurt and no fatalities. So I'd like to close here, and if you're interested, we have this book on the geology of the Canary Islands, which I recommend highly. It also has excursions attached to it, and you can buy this on Amazon, but if you ask me, I can also send you a PDF. So thank you very much for your time.